In this video, we're going to work with the layout that we created in the design part of this tutorial. We're going to take the vectors that we made and we're going to assign them onto specific layers that are related to the type of toolpath that we would allow to calculate for those specific shapes. We're then going to show you how, using the vector selection function within the toolpath forms, we can actually pick vectors based on specific criteria to do with their shape, whether they're open or closed, or what specific layer they lie on. We're going to then calculate a single set of toolpaths for one of these pieces. I'm going to show you how to add the tabs to hold the part in place, and then when we're happy with the preview for that, we're going to show you how we can take that single object, use the true shape nesting function to fit multiple copies of it into a larger sheet of material, and then recalculate all the toolpaths very quickly based on this previous organization that we've done between the layers and the vector selection function within each toolpath. So let's go ahead and start a new copy of the software. So we'll come over and click on the icon to open an existing file. From the project folder, I'm going to select the file widget-vector.crv, hit open, and here you can see the vector design layout that we created in the first part of this tutorial. For this example, what I want to show you is how we can use the layers in the software to manage the vectors that we've got and help us when it comes to selecting those vectors when we're calculating toolpaths. As we progress through, you'll see that that has a number of benefits to us, particularly if we start to make multiple copies of the same object that has previously been toolpathed in the software. So let's come down and click on the Layers tab. And first I'd like to select this rectangle here, then holding the shift key down I'm just going to drag a box around these 4 rectangles, so we have all 5 of those selected now. I'm going to right mouse click here and I'm going to choose the option to move to layer, and I'm going to select new layer. Here I'm going to type the name recess rectangles. And at the moment I don't want that to be visible or active, so I'm going to check those off. So when I hit OK, we should see those disappear, but we should also see that a new layer has been created here. So if I hit OK, we can see that they've disappeared, we can see we've created this new layer, and I can see from the light bulb that that is currently invisible. If I click on the light bulb, we can see that's going to display the objects on the layer. I can click on it again to switch that off. Next, I'm going to select the text here, right mouse click, move to layer, new layer, and we'll call that single line text. I'm going to make that layer invisible and inactive as well, and hit OK. Next, to show you another way we could do this, rather than selecting the objects and moving to layer, we could also say add new layer here over in the layer manager. If I click on this, it's going to create a new layer for me, and I could call that layer drill holes, click, and then we could go ahead and select our objects to put onto that layer. So there, I'm just clicking around, holding the shift key down, right mouse click, move to layer, and if I have the layer I want to move them to already created, then I just need to select that from the list rather than clicking on the new layer. In this case, I'm going to click on drill holes. We don't see them disappear because at the moment that layer is currently switched on so that the objects on it are visible. If I want here, I can uncheck that, or we can check that back on again. So we'll switch that off for a moment. Now you may have noticed there that when we made that layer invisible, the text turned red. That's because it's the active layer. So in effect, the software is giving me a warning that if I was to create something new, draw a new vector or offset something, then that would be created on the active layer, which is this one which is currently invisible, and therefore that layer would switch on again. So typically when you see the red text, what you probably want to do is decide if that is the one that you want to still be active, or if maybe you want to select a different layer to be active, which is potentially one that's already drawn. So here I'm going to come back to layer 1. We're left with just this on this layer, so I'm going to click on the name there and we'll change that to outline shape and just click there. Now, as well as giving layers names, and switching them on and off, another tool we've got to help us keep them organised is to change the colour of the data that's on a layer. If I switch on so we can see all the data again, this drop down box here, so I have the black square here, if I click on the little arrow below that, it gives me a choice of colours. So if I wanted to, I could choose different colours so that when the vector's not selected, it will take on that colour. So there you should be able to see that that vector's become green. The recessed rectangles, maybe we'll make those red, so that becomes very noticeable. The single line text here, maybe we'll choose that to make that blue. So again, changing the colours of the layers is just a technique that can make it easier to see what objects are on a particular layer as you start to organise your data. It's important to understand that there's no right or wrong way to use the layers. The main thing to realise is that they're a way to organise your information, to allow you to switch things on and off to make it easier to select things, and also, as you'll see in this example here, a good way to select vectors when you start to calculate toolpaths. How you use them though, how you colour them, how you name them, and everything like that is just going to be down to the way that you want to work and how they can benefit your particular workflow. So at this point, I think I'm ready to go ahead and start calculating a set of toolpaths to cut one of these parts. So I'm going to come down to the Drawing tab. I'm going to click on the icon here to switch to Toolpaths tab. You could also use the F12 function key on the keyboard as a shortcut to do that. When we click on that icon, the Drawing tab closes, the Toolpaths tab opens, and the first thing we always should do before we calculate any toolpaths is to check our material setup. So I'm going to come up to the top here and click on this button that says Set. This will show me the values that we defined when we first set the job up. You can see we have Z0 at the top of the block, which is fine. Thickness of the material is 3/8 of an inch, which is correct for what I want to do in this example. XY datum is lower left corner. We can see that indicated on here with the red square and the fact the ruler says 0 and 0 for the XY coordinates. Rapid gaps look reasonable. I'm going to put in 1/2 inch for the Z value for the home start position, and I'll hit OK. Now before we start calculating toolpaths, if you're planning to cut this job yourself, you should note that it's important that you put values in that are going to be safe and are going to work for your particular setup, your tooling, your machine, your material, etc. Now typically we would select the objects that we wanted to toolpath and then click on the toolpath icon and then enter the parameters. In this job though, what I've done is by organising these vectors onto the layers that we've created, which are basically defined by the type of toolpath that I would like to calculate on those shapes, I'm going to use a function within the form to automatically select those vectors. So the first thing I want to do is pocket inside these rectangular areas, so I'm going to click on the pocket toolpath icon. The start depth is going to be 0, cut depth is going to be 1/8 of an inch. I'm going to select a tool, we're going to select a 1/4 inch end mill and hit OK, and I'm just going to uncheck this use larger area clearance tool. You may or may not have that already selected there. That will just purely be based on what you were previously doing in your last job. So make sure that's unchecked. We're just going to pocket these out with this 1/4 inch end mill. We can choose whether to offset and follow the shape of those rectangles, or we can raster within them. In this case we'll go ahead and raster, and we have a choice of whether to no profile pass first or last, and in this case we'll just profile around those shapes last. Happy with everything else, but before I hit calculate, you've got to remember we haven't selected anything to calculate this toolpath on. What I'm going to use is this vector selection area of the form here. So it says vector selection is currently set to manual. I'm going to set that to automatic by clicking on the selector button. I'm going to tell the software that in this case I want to machine closed vectors, and I only want to machine closed vectors on a particular layer. So it's going to say selected layers only. I'm going to choose the option for recessed rectangles. So now that's only going to machine any closed vectors it finds on that particular layer. And what I'm going to tell the software now is not just to select those vectors for this one time, but to associate those vectors, or to associate this selection mode with this toolpath, so any time that I recalculate this particular toolpath, it's going to look for that same set of selection criteria. So I'm going to click on this checkbox here to associate with toolpath to do that, and we'll hit close. We'll call that pocket rectangles and go ahead and hit calculate. So you can see there that even though I didn't click anything within the 2D view, the software has automatically gone ahead and used those parameters I set up in the vector selector to choose the vectors and to calculate the toolpath within those areas. So you saw there, after I hit calculate on the toolpath form, the software automatically opened the 3D view and opened the preview toolpath form once it had finished calculating. Now I'm going to choose an appropriate material colour for this, and in this case we're imagining we're cutting a little plastic component. So I'm going to come down to the bottom of the list here and click the pale blue plastic for our material colour. Then I'm going to go ahead and click on the button to preview selected toolpath. Now we can see that showing me the areas that are going to be machined out. If you want to be extremely clear about the parts that you're machining, you can always assign a different colour to the toolpath. So I can click on the button here for toolpath colour, and then I could choose a colour to associate with that area we're machining so that we can differentiate it from what's around it. So maybe we'll choose a yellow colour for this, and there we can see very clearly the part that's being cut, the area that we're machining with that particular operation. So once I'm happy with that, I can go ahead and hit close on the preview toolpath form. And now what I'm going to do is I want to be able to see the 2D view to select my vectors for the next operation, but I'd also like to keep the 3D view visible as well. So we're going to come up to view and say tile windows vertical, and that means it'll show me on the left hand side here the 2D view and on the right hand side the 3D view. Next, we're going to calculate a toolpath to machine the text. Now in this case, our text is a single line, if you remember. So when we generated this, we used a single line font. It's available within the software. And all that I want to do with this single line font is take a V-shaped cutter and just have it go in a certain depth and then go along those lines in order to etch this text. So to do that, because I just want a toolpath that's going to follow the lines, I'm going to use the profile toolpath, and we're going to profile on the vector. And the same as we did with this rectangular shapes, I'm going to use the fact that we've previously organised our data onto specific layers in order to help me select the vectors for the text. So I'm going to come over, click on the icon for a profile toolpath. In this case, I want to etch this text in the bottom of the pocket we've created here. If you remember, we machined this down to a depth of 1/8 of an inch, and I can see that if I hover my cursor over it at the very bottom of the screen, at the edge of the border of the interface, you can see it's displaying the XYZ coordinates for the cursor. That's down in this area here. Again, if I move that over, it's telling me that that's at negative 1/8 of an inch. So my start depth for this is going to be 0.125. I already want the software to realise I've machined down 1/8 of an inch there. Cut depth for this I'm going to specify as 0.05. I'm going to select a tool, and in this case I'm going to choose 60° V-bit and go ahead and hit OK. Now I'm just going to take the parameters from the tool database. Machine vectors, I'm going to choose the on, so what that's going to do is put the tip of that tool, the center of that tool, onto the vector, push it down to this cut depth, and then just machine along those vectors in order to etch my text. As before, I'm going to use the vector selection tool here, so I'm going to hit selector, type of vectors to select. I'm just going to say all vectors basically, so open and close vectors, but only on the layer called single line text. And again, I'm going to associate that with the toolpath, so that if I recalculate that toolpath, then it's going to automatically look for the same criteria of selection in order to apply the values of the toolpath. So if I go ahead and hit close, it's showing me in pink what's been selected here, and now I'm going to call this profile text, hit calculate, and there we can see our toolpath. Now I may want to zoom in the 3D view here, and we could go ahead and say preview selected toolpath. Now I can see when I machine that that that's probably a bit deeper than I wanted to go. That's a little bit more pronounced. I want it more etched. So at this point I might click on the button to undo last to get rid of that. I can double click the toolpath name from the list here for the one we just calculated, and I can change the cut depth. Maybe we'll change this down to 0.03, hit calculate again, toolpath is recalculated, and we can say preview selected toolpath, and I can see that looks a lot better. So we'll just hit the ISO view there to reorient our 3D view. I'm going to hit close on the preview toolpaths form. So the next operation is to create our drill holes. I'm going to use the same method that I've used previously in order to select these vectors. So I'm going to do that from the toolpath form itself using the vector selector. So we'll come over and click on the icon to create a drilling toolpath. Start depth is going to be the surface of the material at 0. Cut depth is going to be the thickness of the material, 0.375. I'm going to select my tool, and in this case I'm just going to choose the 1/4 inch end mill, standard 1/4 inch end mill tool to drill these holes out. This is fairly soft material, so that should be fine. I'm going to hit OK. Have the choice if I want to activate or not activate PEC drilling. If I have this checked, what the software is going to do is machine down the PEC depth, which is determined by the pass depth that you've got set for that particular tool, and then when it gets to that depth it's going to retract out by this distance here in order to try and help clear the chips. So it really depends what type of material you're cutting and the type of tool that you're using as to whether this would be something you'd use or not. In this case we'll just keep things simple, and I'm going to uncheck that option. Vector selection is going to be done automatically again, so I'm going to click on the selector button. I'm going to say this time that I want to just machine closed vectors, and I could be more specific if I wanted. In this case, because I'm drilling holes, I may say that I only want to select circles. So in this case, closed vectors, only circles. I'm just going to say all circles, but I could even get more specific and specify holes of a particular size as well. Here I'm going to use the layers again though. I'm going to say only machine vectors that you find that satisfy this criteria on the layer called drill holes, and again, very important, I'm going to check the box to associate with the toolpath. Hit close. We can see those vectors have been selected, and we'll just call this drill holes and hit calculate. There we've created a very simple toolpath. We can preview the selected toolpath, and there we can see that is machining all the way through our piece of material. So let's close the preview toolpaths, and for my final toolpath I want to do a profile cut around the outside of our part. Again, I'm going to use the vector selector in order to choose the vectors that we're going to machine. So I'm going to click on the profile toolpath icon. Start depth is going to be 0, cut depth is going to be the thickness of material, 0.375. I'm going to hit select and choose the 1/4 inch end mill in order to do my profile pass around the outside of the job. I'm going to hit OK. Then I need to change my machine vectors option here. Remember, the last thing we did was etch the text where we machined on the vector. Now I need the tool to come around the outside of this vector in order to cut out this shape. I'm going to choose the vectors here before we go ahead and make other adjustments to this. Click on the selector button. I'm going to say that I want to select closed vectors. I know that's a closed vector in this case on the layer outline shape, and again I'm going to associate that with the toolpath. So I'll go ahead and hit close on there. I'm going to change the name to profile cutout, and what I want to do here is calculate this toolpath, but this time I don't want to go into the preview function. I basically want to allow myself the ability to take a look, see how the toolpath looks, and continue to make adjustments to it. And I do that by holding the control key down on the keyboard when we press calculate. So remember, ordinarily if I press calculate now, the toolpath would calculate and the preview form would open. Here I'm going to hold control down, I'm going to hit calculate, and now what happens is the toolpath calculates, but the form remains open, so that if I want, I can take a look at what I've calculated and then continue to make changes to it by making additional alterations within that function. Now at the moment, this toolpath is going to cut my part out, but it's going to have nothing to hold it down unless I'm using a hold down method like a vacuum or tape or something like that. On my particular setup, I'm going to need to add tabs to allow the part to continue to be held in place by still being attached to the main piece of material after we're done cutting out. And then what we'd do is manually remove those afterwards. This is a very good way to hold your parts in place if you don't have a vacuum or another way to keep the part held down to your table surface. So I'm going to come down to the area of the form here where it says add tabs to toolpath. I'm going to check the box there, and I'm going to specify the length and thickness that I would like these tabs to be. In this case, I'm going to make my tabs reasonably small. I'm going to make them 1/4 of an inch long, and I'm only going to make them 0.05, so 50 thousandths of an inch thick. That's the Z thickness of those tabs. I don't want to create 3D tabs. I want normal rectangular tabs. The 3D tabs would create as kind of a pyramid shape. And then I'm going to click on the button that says Edit Tabs in order to actually specify where these tabs are going to go. I can add tabs by specifying a constant number and just hitting the Add Tabs button. The software will just put those in at equal spacing around the outline. Or I might want to be more specific about where those tabs go. I can come over into the 2D view and you'll see these tabs displayed by these little yellow squares with the letter T in them, and I can click on any of those and drag those to move those to a new position. Or it may be that I just want to say delete all tabs, and instead of adding them using the values up the top here, I could just come in and click where I would like those tabs to be. So you can see as I come over the profile edge, I get a check mark, and if I click there, it's going to add a tab at that position. So I'm going to add a tab on the top and the side there, and we'll add one on the bottom edge here, and in this case I'm going to I believe they should be enough in order to hold this part in place. But you would just need to make sure you had a sufficient number and that they were sized correctly so that it would be safe for whatever you were doing when you use tabs. When I'm happy with those, I can go ahead and hit close. Now I'm going to hold the control down and hit calculate again. So now what we should see is, if we look at this carefully, there is a lift as it comes around here. It's going to lift up there, come across, and then plunge back down again and carry on. So it should leave a small piece of material there. We can double check that if we want. I could close this now. We could click on the preview toolpath button and we could go ahead and preview it. So if I say preview selected toolpath, I can look there, and it's a little tricky with the blue material and the blue background to see those, so maybe we'll just change this, and I'll change it to a darker blue, and there we can see those tabs being left there and how they're going to hold the part in place when this is cut out. And as I said before, you'd actually take the part off then, including the stock material, and just remove those manually or with a saw or something like that. So you've already seen how invaluable the toolpath preview is to let us see exactly what's going to happen based on the parameters we've set up for our toolpaths. If we maximise this, you remember we were able to clearly see what the text was going to look like when we machined it and adjust the depth before we'd actually run the part, wasted time or material on that. In addition, I can see another issue that I need to address here is the fact that I've generated these rectangles to pocket these areas out, and that's fine. I would expect, it's pocketed within there and it's left the radius of the tool on each of the corners. The only issue being that on this far right hand edge here, what I actually wanted is for that to pocket all the way through and leave a straight edge on these sides here as it got to the edge of my part. To achieve that, what I'm going to need to do is extend those vectors slightly outside of the job to allow the tool to come past there so that the radius it leaves is not within the side of the part here. So let's go into the 2D view. I'm going to come up and click on the tab here where it's got the name of the file. That's going to take me back into the 2D view. what I'm going to do is edit my 4 rectangles on the side here. So let's close the preview there, click on the icon here to switch to drawing tab, so that closes the toolpath tab, opens the drawing tab here. What I want to do now is select those 4 rectangles. I'm going to come over and click on the icon to set selected object size, and what I want to do is extend them to the right. So I'm going to anchor this on the left, so in this case we'll just say top left corner as my anchor position, and I only want to extend them out horizontally. I don't want them to scale horizontally and vertically, so I'm going to uncheck the box to link XY, and then what I'm going to do is extend their width. And in this case I'm using a a quarter-inch tool to pocket these out, so I need to make sure they extend past the edge by the radius of the tool. So I need to add the radius of the tool onto here. I could either manually calculate that, or if I wanted to I could enter that as a calculation into the software directly. So there I've got my original size, and what I could say is plus 0.125, which is the radius of the tool, remember, not the diameter but the radius, and then hit equals on the keyboard to calculate my value. Now if I hit apply, what that's going to do, because these are anchored on the left, is extend that out by whatever the new value I've put in there is, but maintain the height of those vectors because we unchecked link XY. Now I can close that, and what I can do is hit the icon here to switch back to the toolpaths tab, and we should just be able to double click on the pocket rectangles toolpath, or I can select it and click on the icon to edit the toolpath, and then I shouldn't need to do anything except hit calculate, because it's automatically selecting these vectors, and they are still the same vectors. They're still on the layer that we had them on before. They still meet the selection criteria, so it's automatically going to pick those up even though we edited the size. So when we hit calculate, we'll get a new toolpath, and what I should be able to do is just say preview that selected toolpath, and we should see those little radiuses in the corner disappear when we do that. So I'm going to click preview, and there we can see now it's machining past that edge based on extending that area outwards, and I've got the effect I was looking for. Once we're happy with the way the part looks in the preview, then we're ready to save our toolpaths out to the CNC. We could close the preview here, and then it would just be a case of selecting each toolpath in turn, clicking on the Save Toolpath icon. See here that it will list the toolpath to be saved. We click on the post-processor list here. You choose whatever was appropriate for your particular machine and click on the button to save toolpaths. Navigate to an area on the PC, give it an appropriate name and hit save. Once we've done that, we'd choose the next one, hit save, choose the next one, hit save, choose the next one, hit save, and then take those out to our machine. Once we'd cut this, if we were happy with the way the part was, or maybe we'd created a prototype and we'd sent it to the customer, and the customer had told us that he now wanted to order a number of these to be made, we'd really start to benefit from the way that we'd set this part up by taking the time to associate vectors onto particular layers, and then to use those layers to help us select the vectors when we calculated the toolpaths. And so what I'd like to do is show you how we take advantage of that now if we were to create multiple copies of this part. We'll also look at the tool to help you orient as many of these pieces within a piece of material, which is called true shape nesting. So to do this, I'm going to go back to the 2D view so we can see our two-dimensional data here. Just going to click in the background to deselect everything, and I'm going to click on the icon here to switch back to the drawing tab. So what I'd like to do is first change the size of my material to the size of the piece we're going to use to try and fit as many of these in as we can. So I'm going to come over, click on the icon to set job dimensions and origin. In here I'm going to tell the software now that my new piece of material is 36 inches by 36 inches. I'm going to leave all the other information as it is, so same material thickness, same date and position, and hit OK. as it warns me there, changing anything to do with this means that you do need to recalculate all the toolpaths before you proceed in order to make sure they match up with whatever your new settings are. That's fine, we are going to do that, so I'm going to hit OK. I'm now going to drag a box to select all the vectors that we've got for the design of our part, and come down and choose the option here to nest selected vectors. Within here we're going to specify different parameters to see how best we can nest these in order to fit as many as we can within our sheet. The first thing is I'm going to specify my tool diameter. Essentially this is the tool diameter I'm using to cut out the part. So I'm going to put in 0.25. Next I want to decide if we want to leave additional clearance between the parts. So let's start by putting in a 1/2 inch clearance, and we'll leave a border gap of a 1/4 inch as well, and what that is an additional clearance around the edge of your part, potentially to allow for you to clamp the part, screws or something like that. Here I can choose various options again to try and give me a better fit. This would depend on the part I'm cutting and the material as to which of these I could select. For instance, if grain direction was very important, then I may want to uncheck this to not allow the software to rotate the parts. In this case I'm cutting plastic, so I'm not too worried about that, and what I'll probably do is start with a step angle of 90 degrees in here and just see how that goes. I don't want the software to mirror the parts. In this case I need it to be in this direction. I don't want to allow parts inside of other parts. In this case it's actually not really suitable for that. That may be if you had something that had extremely large internal shapes, such as a big letter O or something, where you may fit additional shapes. We choose which corner we'd like to nest from and whether we want to nest along X or Y. Software will do both, but this is just to help it to choose which one, in which direction to start in effect. Next I need to tell it how many copies I want to create of this. So what I'm going to do is type in 18 in this case. It'd be great if I could fit 18 pieces into this sheet. I'm going to hit apply and the software will show me the number I've put in there on each of the vectors that I've got within the part here to show that's how they're going to be nested. Next what I do is I hit the preview button and that will show me how many pieces it's managed to fit within my part based on this particular set of parameters that we've entered. So I can see there it's fitted 4 by 4, so 16 parts in. As soon as I nest something where it won't fit all the parts in, then they're going to go on what's called another sheet. So if I was to just zoom out from this a little bit, so if I click in the 2D view here and just zoom out using the mouse wheel, you can see that what we've got is this additional area here, and that's showing me that I've now got one sheet here and another sheet here. If I wanted to make this sheet active, I could just double click on it to see those parts. And if I couldn't fit them all into a single sheet of material, then at least this would allow me to cut toolpaths for the first sheet, then calculate and cut toolpaths for the second. In this case, what I'm going to do is come back to sheet 1 here, and I'm going to try adjusting some of my settings to see if we can get those two parts to fit within this material. One thing we might try is a different step angle on here, so maybe let's enter a step angle of 30 degrees instead. Let's go ahead and hit preview, and the software now will rotate each object in 30-degree increments to see if we can fit that better within the part. And we can see we've now managed to get 17 of the 18 to fit. So now what I might try is saying, well, I've got a 1/2 inch clearance there. Perhaps if I reduce that a little, I could stand to reduce that distance a little bit more, then I may fit that last piece in. So I'm going to say instead of 1/2 inch, let's leave an additional 0.4 inches between each of the parts. Let's hit preview. And now we can see it's not requiring any extra sheets. It's managed to fit all the parts inside of my piece of material. And I'm happy with that. I can hit OK. And then we'll just come up and hit the zoom to fit icon here. So the true shape nesting is a very powerful way to maximize your yield within a piece of material. One thing that the nesting does, which is very helpful, particularly in the way that we've set this part up, is it will actually retain the layer, the original layer information for the parts that you've nested. So if we come down to the Layers tab and I go ahead and make the outline shape invisible, you can see they all become invisible because all those outline shapes are on the same layer, all the recessed rectangles are on the same layer, all the text is on the same layer, and all the drill holes are on the same layer. Now you can already probably imagine the benefit of that because we've associated with particular toolpaths that they should pick vectors on a particular layer. So now the software, if we recalculate those toolpaths, will automatically use that vector selection because we associated it with the toolpath in order to pick everything on that layer to correspond to the criteria that we set up. So if we look at that in action now, let's come down to the Drawing tab, click on the icon to switch to the Toolpaths tab. Over here, I could either double click on each toolpath individually and recalculate it, or I can just come up and click on the icon here to recalculate all toolpaths. So if we click on that, the software will go ahead and execute that. It says all toolpaths have been recalculated OK. I can hit OK there. I can see all the 2D previews. If we were to go ahead and tile the windows, so go up to View, tile windows vertical, we can see the 2D and the 3D version of what's going on there. So let's maximize the 3D view, and then we'll just work our way through and preview each of these toolpaths. So I'm going to go with the pocket rectangles. I'm going to click on the preview icon and we'll just say preview selected toolpaths. So there's all those. Click on the profile text, preview selected toolpath. There we can see those. Next, the drill holes, preview selected toolpaths, there's all our drill holes. And finally, the profile cutout. We preview the selected toolpaths. We can see that not only has it retained the layer information, but because we'd associated tabs with that vector, the tabs are now in the same place on all the copies of that vector that were made with the nesting function. Now it may be that because of the way these have been nested, that some of those tabs are no longer in a place which is optimal or appropriate to hold it once it's cut out. So you can still manually go in and edit these even after we've calculated the toolpath in this way. To do that, if I go back to the 2D view so we can clearly see those, I'm going to close the preview toolpaths. I'm going to click on the profile cutout toolpath and click the icon to edit that toolpath. There you can see those tab positions are all being displayed. So if I wanted to move those, what I would do is click on the button here to edit tabs, and now I could zoom in and I could manually click and move these if they were in a place that wasn't optimal for the part to be held when it was cut out. So you can see that would take a few minutes to work my way around, but I have the ability to go in and override those original positions, just dragging these into new places that I think would be better than where they were originally placed. I can hit F on the keyboard to fit the work area back into the window. So once I'd finished making all those edits, I'd just go ahead and hit close and calculate, and the new tab positions would be calculated for the most recent iteration of that toolpath. Again, we could reset the preview all the toolpaths, and that would go ahead and show me the new tab placements of the parts that I'd moved, such as these two here and here. So I'm not actually going to go ahead and move all these tabs in this case. If you were going to cut this part, you would probably want to take the time to do that. Here I'm just going to save this file, go up to File, Save As, and we'll call this widget TP to show it has toolpaths in it. We'll save that in the project folder. You could take a look at that if you want to see exactly the way I've set the part up here. Let's take a moment now to summarize what we've looked at as we've worked through this example. We started by opening the vector layout file that we'd created in the design part of this tutorial. Our first task was to take those vectors and to assign them onto particular layers using the Layer Manager. These layers were directly related to the toolpaths that we planned to calculate on those specific vectors that we assigned to each particular layer. And this was done very specifically because we wanted to use the vector selector function within the toolpath to allow us to choose particular vectors that we wanted to apply the toolpath to. Then we worked through calculating a set of toolpaths for a single one of our objects that we wanted to machine. If you remember, we calculated the pocket toolpath first, then we used the profile toolpath to use a V-bit cutter to machine on the font we'd created, drilled the holes, and then created the profile toolpath around the outside, adding the tabs to hold the part in place. We then had to make an edit to our design because we saw in the 3D preview that our pocket toolpaths were not going to extend far enough past the edge of our part. So we edited the vectors and recalculated that set of toolpaths, and at that point we'd created toolpaths that would cut a single component perfectly. Then we talked about the fact that if we wanted to, we could now create multiple copies of this, and this would be much easier to do because we'd done that association with the toolpaths using the vector selector to particular vectors on certain layers. So we went to the job setup, we increased the size of our job to our new sheet of material, and we used the true shape nesting in order to try different settings to try and optimize how many parts we could fit within that sheet. Once we'd done that, because we'd done our work earlier with the vector selector, our layers, and with the way we'd set the toolpaths up, it was very simple for us just to hit the button that said recalculate all toolpaths for the software to work through those toolpaths that we'd created before and to calculate them for all the parts we'd now nested to make this a very efficient way to cut lots of the same object. So that concludes this tutorial.